Hello everyone, I hope you're doing well. I am Hamdani Ilham. Today my companions Abdurrahim Days and Awatif Ohami and me will share with you our project in MATLAB GUI, framed by Professor Abdulatif El Ghazi. First, we're students at the International University of Rabat as Future Engineer of Renewable Energy. So before sharing project, we want just to make you aware about the definition of MATLAB and MATLAB GUI. So what is it? MATLAB is the abbreviation of Matrix plus Laboratory. It's a high-performance language for technical computing. It integrates programming in an environment where problems and solutions are expressed in mathematical notation. Typical uses include data analysis, exploration, and visualization. MATLAB contains many interfaces, like the interface called GUI, Graphical User Interface. It makes things simple for the end for the program. So I will show you how we use it. So first, open up MATLAB, go to command window and type in guide. In the guide, select the blank GUI default, then click OK. You should now see the following screen. In there we have many components such push button, slider, edit text, static text when we can add the text, axes for graph and pictures. So for example, let's create an interface. We show in the end of the program a text such hello dear user. So to do that, add the push button, an edit text, and a static text. Double click in the push button, and there we can change in this inspector the background color, change the size. We can change string, which is an array of characters. Change the tag. In purpose to call is called back in the program. Foreground color. And do the same for this for the edit text and the static text. And if you want, change the background color. Then save the program. And here we go, our program is opening. So go to show callback and execute the following code. Save it and do run. In this interface, click in show push button, and yes, you see hello dear user. So this is a simple example for how we use MATLAB GUI. So now I'm going to share with you our project design. So I open our menu.m, I do run, and as you see, our menu contains 12 codes. So I present the first codes. I start by the one. It's about calculator, scientific calculator. This interface makes it possible to do the various manipulations. To program it, we need to create an interface, which we need to use boxes of types edit text, as well as boxes of type static text. And those buttons 1, 2, 3, cosinus, sinus, they are of type push button. So let's test the program. For example, I want to calculate the factorial of number 4. I click in 4, factorial, and here we go, our result is 24. I create the program and, for example, calculate cosinus p, and the result is -1. So I pass to the second code. So the program number 2 is about function. In this interface we have push button derivate. So this program can derivate the function, calculate the limit, do plot by different methods, 3D, bar, stem, and plot. So let's enter the function. Click in derivate, and x tends to 0. I click a limit. As you see, sinus 0 is 0. And I do plot by plot, 3D, bar, and stem. I return to the reception, and for the next code is about Reynolds and charges. So as you see, we add some programs in other subjects like fluid mechanics. Due to MATLAB, we can also calculate number of Reynolds that show us flow types. And if Reynolds, which equals the multiplication of the speed and the diameter divided by the kinematic viscosity, is less than 2000, the regime is laminar. And if Reynolds is between 2000 and 4000, we say the regime is transient. And if it is more than 4000, the regime is turbulent. So for example, I entered the value of the diameter, so then I calculate Reynolds. As you see, Reynolds is more than 4000, then the type of the flow is turbulent, and this is the figure of the flow. So this is the part number 1. For the part number 2 is about the total pressure losses, which equals delta PS plus delta PR. So to do that, first we calculate the lambda, V square, regular pressure drops, and delta PS. So I will show you the program of the push button calculate lambda. So I go to Reynolds program.m, go to calculate callback, as you see we have 3 cases. So for our example we are in the third, so lambda equal this number. So let's test now the program. Calculate lambda, and I click in calculate V square, regular pressure drops, and enter the unit pressure drops, and finally calculate the total pressure losses. So I return to the reception. So now my classmate Abdurrahim Days will continue the presentation.
Program is about method of integration. This program gives 3 methods of integration exists in MATLAB. The first is integral, the second is quad, and the third is trapezoid. For the first is integral. We enter here our function For example, I enter here 1, and if I click calculate, we have a message of error. Enter a value for b. So if I enter a value for b like 2, and then I click calculate, and there is the result is here. So for the second is the same thing like the integral, and then the result is here. And for the third is traps. Traps is gives to a number of sub-intervals. Like I enter 10, and then I click calculate. So I mentioned that the function is will not be used in the future version of MATLAB. So we have here plot. It gives our function here, and then next we have we can change the size of our function like 12 or 10, and we can change the color like green or yellow. Then we will go back to our menu, single and double integration. So for the first is about single integral. We make our function here like x, and the intervals we can make 1 and 2, and then click in calculate. Then this is our result. Second is the double integration, and I will show how we wrote the program be calculate the double integration. So we go back, we open in, then we go to the callback of the push button calculate, and there is the so is we use integral and our function here and the interval of x and the interval of y. Then we go to test this program. So we make our function here like 3x plus 2 y, and the interval of x we make 0, for example, and 5 and 0 and 3. Then we click in the push button calculate, and there is our result. And we go back to our menu, matrix calculator. As you see, we can do many manipulation like calculate the subtraction of the matrix, also addition and multiplication, as well as the program can calculate the trace of the matrix, rank and transpose. So first we have three table, this for matrix A and this for matrix B, and the other table for showing the results. So let's enter the matrix A. 9, 3 and 1, and we click in transpose, and there is the result. And also rank, this matrix is rank 2, and the trace is 5, and 4 plus 1 is 5. So so now let's enter the matrix B, and the purpose to calculate multiplication and subtraction and addition. And there is multiplication and addition and subtraction. Code is about if 0. This code is try to find a 0 of a function near x0. So we enter the function like x, and our value x0 like 2, and we click calculate, and there is the result is here. This is our root. Then we click in plot to see our function. This is the function of x. And thank you so much. Now with my classmates, our chef will continue the presentation.
So guys, in this video I present the last 3 programs. I first covered the interpolation program. Interpolation is a technique that allows us to estimate the value of function for an intermediate value. To program it, we need to create an interface guide, and we use 2 static texts plus 2 array texts to represent 2 vectors that give some values of an unknown function. These 2 vectors must have the same size. For example, if these 2 vectors don't have the same size, let's try. We see an error message. We use the comment message box to show an error message. Okay, so let's add 4 for example. And for an intermediate value, let's try 15 and plot. As we can see, a few data points from the original function can be interpolated to produce a function which is still fairly close to the original function. In this program, we are going to create a temperature converter using guide. We need static text, array text to enter a temperature value, and push buttons to calculate the final result. So for example, take a temperature value equal to 37 Celsius. And we are going to convert that value from Celsius to Fahrenheit, for example. And we have the final result. We can do the same thing for temperature in Fahrenheit. From Fahrenheit to Kelvin, for example, from Fahrenheit to Celsius, and same thing from Kelvin to Fahrenheit. And for ranking, we can enter the temperature equal 54, for example, and calculate. And we have a different result with temperature converter. And the last program is about to learn how to solve second degree equation using MATLAB. In the last program, we are going to learn how to solve second degree equations using MATLAB. In this program, we need static text, array text, and push buttons. We need to enter the value of A, B, and C, where A is the number that always goes in front of the x squared. B is the number that always goes in front of the x, and C is the number without a noun. And now let's see how the solutions of second degree equations can be. For example, A equal 1, B equal 5, and C equal 5. Solve. We have two solutions, a second degree equation with double solution. Now let's try another example. A equal 1, B equal 4, and C equal 4. Solve, and there are only one solution. Let's try third example. Example A equal 2, B equal 1, and C equal 1. Solved. It has no real solution. This sentence is equivalent to saying that solution is found in a set of complex numbers. In conclusion, we can say that this project has allowed us to develop the team spirit present on each member of our group. In addition, we learned the usefulness of several specific functions in MATLAB to solve optimization problems. Knowing that some features are available in the basic version of the software while others aren't accessible. In the end, we would like to express our gratitude to our teacher El Ghazi Abdullatif, and we just wanted to thank you for teaching us and for all the support you gave where we struggled in all the content. Looking forward to the next semester. All our gratitude also goes to the President of the International University of Rabat, as well as to the Director of the Higher School of Energy Engineering. We thank you very much indeed for your interest and will get in touch with you shortly. Please find our contact information on the right hand side of this page. Thanks for watching.